Well done analyzing the two examples we provided for the urban flow of water, an urban black water treatment plant and a suburban development with halophyte filters. In this short video, we discussed some of the advantages and disadvantages that these two examples have, while emphasizing that every circular solution is dependent on the local spatial, economic, and political context. Let us first look at the black water treatment plant. This is a centralized intervention implemented at neighborhood level and run by Waternet, the central institution that manages fresh water and sewage in Amsterdam. One of the advantages of this project is that Waternet is responsible for its maintenance, so local residents have no concerns over the performance of the system. It is a closed system, which means that waste cannot leak and pollute the environment. And a great ecological advantage is that phosphor is extracted in the installation. Phosphor is an important fertilizer used in agriculture, which largely comes from dedicated mines. It is part of the food we eat and gets flushed away through the toilet. It is difficult to regain phosphor from large sewage purification plants. In our example, close to the source, it is possible to regain phosphor and make it available again for agriculture, a clearly circular solution. But there are also disadvantages in this type of system. Firstly, the initial implementation costs are high, as you have to invest a large sum of money to install the required vacuum toilets and the vacuum pipe system in buildings and underground. Hence, this is normally a system that is more likely to be developed by either a public authority or large project developer. The rigidity of the system also makes it inflexible for potential future fluctuations in number of residents. The look and feel of the system is rather industrious, which might make it less appealing for local residents. They might find it difficult to bond with the system or feel that it's theirs. Eventually, the system is vulnerable for individual misuse. If one of the many households connected to the installation, one person discards the wrong detergent through his toilet, the whole system may stop functioning. As the users are quite distant from the system, physically, but also psychologically, they might be more inclined to not use it properly. We then looked at a different solution to wastewater treatment, the suburban development that uses halophyte filters. This is also a solution at neighborhood level and forms an integral part of the ecological landscape plan of the neighborhood rather than an industrial system. Here, circularity takes place on a larger level. The grey water that comes from the different households is filtered and then infiltrates in the ground, where it eventually becomes part of the groundwater that is extracted and used as drinking water. This solution contributes to the ecological and aesthetic values of the area. The system supports local biodiversity and also looks attractive. The initial costs are relatively low, which makes this system interesting for new, low-dense developments, whereas a centralized sewage network would be quite costly. Eventually, the household can and has to maintain its own halophyte filter. You know if something goes wrong, and you are in control. So, you could say that this is a very eco- and resident-friendly solution, but it also has its disadvantages. Because there is this individual control, the operation of the system is very much dependent on good behavior and on maintenance of the system by all the participants. If one resident ignores the rule that comes with such a system, the system may not work properly and pollute the groundwater in the area. In that case, it is very difficult to trace back whose fault it was. So what was mentioned as an advantage is also a disadvantage. Everybody needs to regularly check and take care of their own halophyte filter. Another disadvantage of such a natural system is that it cannot deal with peak inflow very well. If you have a party and more people use your toilet than what the system is dimensioned for, the system may collapse. What we have to keep in mind, though, is what we are doing here is comparing two very different solutions with each other. The first example cleans black wastewater, whereas the second example filters grey water. and both are location specific. The vacuum pipeline of the first system would be too expensive and inflexible in an organically growing, local, low-density neighborhood. And the open halophyte filters may require just too much surface to be feasible in dense urban areas. The spatial context with its organizational and financial counterparts hence determines to a large degree the technical solutions you can implement. Looking at the circularity, we see that water is actually completely circular. It starts its urban life cycle as rainwater or centrally produced fresh water and eventually returns as water again.